Ever feels like your computer is stuck in traffic? Even with all the fancy new tech under the hood? Well, today we're going to explore a hidden bottleneck that was slowing down data transfer and how a clever solution in PCIe Gen 5 finally fixed it.
Yeah, that's right. We're diving deep into understanding transaction tag scaling in PCI Express, PCIe. It's a technical document that reveals how this innovation is changing the game. It's not always about raw speed.
Right.
Sometimes it's about optimizing how data flows.
Okay, so what exactly is this transaction tag scaling and why should we care?
Imagine data packets as cars traveling on a highway. Okay, so in previous PCIe generations, each packet needed a license plate or transaction tag to travel. The problem was there were only 256 unique plates available with the 8-bit tags they were using back then.
Okay.
As data rates increased, this limitation created a bottleneck, even with more lanes on the highway.
So it's like having a 12-lane superhighway but only a single toll booth. Makes sense that would cause a backup no matter how fast the cars themselves can go.
Exactly.
So how did PCIe Gen 5 address this?
Well, they basically upgraded the license plate system. With PCIe Gen 5, we now have 10-bit tags offering 1,024 unique tags. This seemingly small change was a game changer, allowing for smoother data flow and unlocking the true potential of the Gen 5 speed boost, which, by the way, is a whopping 32 GTs.
Wow.
That's double the speed of Gen 4.
Yeah.
And a 16-fold increase from the original PCIe standard.
That's a pretty significant leap, but it also sounds like a pretty complex change. Were there any challenges in implementing this new system?
Absolutely. Redesigning the PCIe controllers to accommodate the larger tag field was a major undertaking. Imagine having to rework the traffic management system for a bustling city.
Yeah. So they didn't just add more license plates, they had to make sure the traffic cops could handle the increased complexity too.
Exactly. They had to overhaul the tag management logic, ensuring each data packet gets the right plate at the right time and that all the requests are tracked and completed efficiently, all while making sure this new system plays nicely with other existing PCIe features.
That sounds like a pretty intricate dance, but I imagine the payoff and performance makes it all worthwhile.
Absolutely. This optimization has far-reaching implications, affecting everything from high-performance computing to the responsiveness of your everyday devices.
Okay, I'm definitely starting to see why this is such a big deal. We've talked about the problem, the solution, and even some of the engineering hurdles, but I'm curious to see how this plays out in the real world. Can you give us some concrete examples of how transaction tag scaling is impacting different applications?
Certainly. Let's start with something many of our listeners can relate to: gaming.
Perfect. I'm all ears. All right, so let's talk gaming. I can already imagine how smoother data flow would be a gamer's dream, but what kind of real-world improvements are we talking about here?
Well, think about those visually stunning, action-packed games that push your graphics card to the limit.
Huh.
They require a constant stream of data between the CPU, the GPU, and memory. With PCIe Gen 5's increased bandwidth and the expanded tag space provided by those 10-bit tags, we see significant reductions in latency, meaning smoother gameplay, faster rendering of complex scenes, and quicker loading times.
So no more frustrating lag when things get intense on screen. Sign me up. But wouldn't a faster GPU alone achieve similar results? I'm curious to know just how impactful this tag scaling really is.
It's true, a faster GPU plays a crucial role, but even the most powerful graphics card can be held back by a bottleneck in data transfer. Imagine a high-performance sports car stuck in rush hour traffic.
Right.
Same concept here. Transaction tag scaling helps eliminate that bottleneck, ensuring that the GPU can access the data it needs as quickly as possible, maximizing its performance potential.
That's a great analogy. So it's like they've paved the way for those high-performance components to really shine. But gaming isn't the only area benefiting from this, right? We touched on AI and machine learning earlier. Could you unpack that a bit more?
Of course. AI machine learning models, especially those used in deep learning, are incredibly data hungry. They need to process massive amounts of information to train effectively. Transaction tag scaling ensures they can access and process this data with minimal latency, which leads to faster training times, more accurate models, and ultimately more powerful AI applications.
It sounds like this optimization is accelerating the advancement of AI in a pretty significant way. I'm sensing a pattern here. Faster, smoother data flow seems to be beneficial across the board. What about something like storage, those NVMe SSDs everyone's raving about, for example?
You're absolutely right. The impact is widespread. And yes, NVMe SSDs are another prime example of how transaction tag scaling is making a difference. These drives are already known for their incredible speed compared to traditional hard drives. But this optimization takes things a step further. By allowing more simultaneous data requests, we see even faster read and write speeds, meaning your computer can access files and load programs even quicker.
So it's like supercharging an already super fast storage device. It's amazing to see how a seemingly small tweak can have such a ripple effect across different applications and devices.
It really highlights the importance of looking beyond raw speed when it comes to performance. Sometimes the key lies in optimizing the flow of information, making the entire system work more efficiently.
Well said. But I have to ask, are there any potential downsides to this? Does increasing the complexity of the system come with any trade-offs?
That's a great question. And it brings us to an important aspect of this technology implementation challenges. While the benefits are undeniable, integrating the larger tag field and redesigning the controllers to handle this increased complexity wasn't a walk in the park.
Okay, so let's talk about those challenges. What were some of the biggest hurdles engineers had to overcome?
One of the main concerns was power consumption. More complex controllers often require more power, which can be a problem, especially in power-sensitive devices like laptops. Engineers had to strike a delicate balance between maximizing performance gains and minimizing any potential increase in power draw.
So it's not just about making things faster, it's about making them smarter and more efficient as well.
Exactly. Another challenge was ensuring compatibility with other existing PCIe features. Remember, PCIe is a complex ecosystem with various mechanisms working together to ensure optimal data flow.
Like different systems within a city, transportation, utilities, communication networks, they all need to work together seamlessly.
Precisely. For example, there's a feature called scaled flow control, which helps prevent data congestion by dynamically managing the rate at which packets are sent. Engineers had to carefully coordinate this feature with the expanded tag space to avoid potential conflict or performance degradation.
So it's like making sure the traffic lights are synchronized to keep things flowing smoothly, even with all the extra cars on the road. It sounds like they had their work cut out for them.
They did. But the fact that they were able to overcome these challenges and deliver a solution that works so effectively is a testament to their ingenuity.
Absolutely. And it makes you appreciate just how much intricate work goes on behind the scenes to bring these technological advancements to life.
And the journey doesn't end there. The pursuit of faster, more efficient data transfer is an ongoing quest.
I can only imagine what innovations are on the horizon. But for now, I think we've covered a lot of ground with this deep dive into transaction tag scaling. We've explored the problem, the solution, the benefits, and even the challenges of implementing this technology.
And hopefully our listeners now have a deeper understanding of just how impactful this seemingly small tweak is, affecting everything from the games we play to the advancement of artificial intelligence and even the responsiveness of our everyday devices.
It's a great reminder that innovation isn't always about flashy new features or bigger numbers. Sometimes it's about optimizing the core systems that power our technology, making them work smarter and more efficiently.
Well said. And as we wrap up this deep dive, I'd like to leave our listeners with a final thought. If such a seemingly minor change can have such a profound impact, what other hidden bottlenecks might be lurking in our technology, just waiting for a clever solution?
That's a great question to ponder. It makes you wonder what other seemingly insignificant optimizations could unlock whole new levels of performance and efficiency in the future. It's fascinating to think that there might be all these other hidden performance bottlenecks lurking just beneath the surface of our technology. Kind of makes you wonder what other clever solutions are out there just waiting to be discovered.
Yeah, it really does. And that's the beauty of engineering and innovation. There's always room for improvement, always a challenge to solve.
Well, speaking of challenges, we've touched on some of the hurdles engineers faced when implementing this expanded tag system. Power consumption, compatibility issues, it sounds like they had their hands full.
Oh, they certainly did. But let's dig a bit deeper into those technical challenges. One of the key hurdles was ensuring the redesigned controllers could handle the increased complexity without compromising efficiency. Remember, we're talking about a system that's managing a constant flow of data packets.
Right.
Each with its own tag, request, and completion status.
It's like air traffic control for data packets. I can imagine that gets pretty complicated, especially with the larger tag space and PCIe Gen 5.
Exactly. One specific area where engineers had to focus their efforts was request queuing. The mechanism within the controller. With more tags available, the potential for queuing conflicts increases. Imagine a scenario where multiple requests with different priorities are vying for the same resources. The controller needs to manage this queue effectively.
Right.
To ensure fairness and prevent certain requests from being starved while others get preferential treatment.
So it's not just about processing more requests simultaneously, it's about processing them intelligently and prioritizing them correctly.
That's right, and that requires some clever algorithms and intricate logic to be built into the controller's design. They had to consider factors like request type, data size, destination, even the age of the request. all to ensure the most efficient flow of data.
Wow, that's a lot to juggle. It really highlights the level of complexity involved in optimizing a system like this. But I imagine the performance gains are well worth the effort.
Absolutely, and the impact goes beyond just individual components. This optimization has implications for the entire system architecture. Think about how data moves between different components like the CPU, the GPU, and storage devices. With transaction tag scaling, we see improvements in overall system responsiveness, reduced latency in data-intensive tasks, and even potential reductions in power consumption, as data flows more efficiently.
It's amazing to see how something that seems so technical can actually translate into a better user experience for everybody. Faster loading times, smoother gameplay, more responsive applications, those are things everyone can appreciate.
Exactly. And while we focus primarily on the technical aspects of transaction tag scaling, it's important to remember that this innovation is ultimately about, enabling better, more powerful computing experiences. Whether you're a gamer, a creative professional, a data scientist, or just somebody who relies on their computer for everyday tasks, this optimization is playing a role in shaping the future of how we interact with technology.
It's a great reminder that innovation isn't always about flashy new gadgets or groundbreaking discoveries. Sometimes it's about making those subtle but significant improvements to the underlying systems that power our digital world.
And that's a great note to wrap up our deep dive. We've explored the what, the why, and the how of transaction tag scaling, uncovering the hidden bottleneck, the clever solution, and the real-world implications of this technological advancement.
I think our listeners now have a much deeper appreciation for the intricacies of data transfer and the brilliant minds that are constantly pushing the boundaries of performance and efficiency.
Hopefully, this deep dive has sparked some curiosity and perhaps even inspired some of you to explore the world of technology and innovation further.
And on that note, we'll leave you to ponder the possibilities. Thanks for joining us on this fascinating journey.